Hello there. Welcome to the third video in the series AI for Everyone. Are you looking at a hands-on approach to develop your first deep learning experiment? Well, you are in the right video. In this video, we will look at a hands-on approach of developing your first deep learning experiment using Keras and TensorFlow. This one will let you jumpstart your AI journey. Well, in your deep learning venture, the first step is to define the purpose of your venture. What are you planning to solve? What's the business problem statement? Let's see an inspirational example from Google.
I see circle, or lollipop, or spoon, or dumbbell. Oh, I know, it's balloon. I see line, or shoe, or square. I see camera, or map, or washing machine, or oven. I see spreadsheet, or window, or radio. Sorry, I couldn't guess it.
The book Deep Learning with Python has been instrumental in creating this set of videos with the code examples. The book by Francois, AI researcher at Google, is aimed at democratizing AI, and that's the sole intent for this video series.
The first step is to define the purpose. And as you define the purpose, we need to plan if we can collect data representing the world that we want to define. For example, an app idea to predict your health using your handwriting. Handwriting reveals a lot. So, various health labs request patients to write and draw few basic patterns, and based on that, they are able to identify the type of the patient, whether he is healthy and normal or he is having tremor in handwriting, and even identify certain special diseases. So, can your handwriting define your health? Well, it could be an app idea, and that's what we will look at now. In this video, we will begin this journey of experimenting with how do you actually define a deep learning project that looks at handwriting. A simplified business problem needs to be created. An idea here is to probably look at a gesture lock where you draw something on your screen and the phone unlocks. To begin, we will simplify this goal so that we take a most simpler approach based on the data that's available. What are the steps that you need to follow? The first one is to actually define your problem. What's the purpose? Next, we need to collect the data representing the purpose. Then we need to actually prepare the data so that deep learning models can be employed. So we need to split the data into training and test and validation data, do few operations such as normalizing the data, vectorizing it into tensors, reshaping it to the right set of data formats that can be fed into the neural networks. Then we need to define the network itself. We can play around with different network architectures and find out which architecture best suits the data that needs to be represented. The next one is to define the optimizers such as logs functions and various optimization models. The next one is to actually train the data on the training set that you have compiled and created. Once you have that, we need to validate whether the model represents the data, and based on that, evaluate and improve the model. Finally, predict with test data set and then deploy it. So this is the basic 7 steps to create your first model, and then we'll have to iterate back to plan more networks. Once we have the first model of the data that needs to be represented, we can go back to step 3 to redefine various new network architectures and iterate and find out which model actually represents the data in the right way. Once you have accurately defined the business problem statement, the next step is to actually collect the data representing the world that you want to predict. For example, here we want to recognize handwritten digits, so a labeled data set needs to be created. Next, we need to load the data and then visualize it. Fortunately, Keras has various data sets. You can quickly visualize the data that has been loaded. Next, we need to prepare the data. Here, the first step is to actually split the data that's available for training as well as testing. Later on, we will also refine this to actually include a validation set so that the deep learning training model becomes more effective and more accurate. General rule of thumb is to actually split the data as 70 percentage for the training set and the rest for test. In this example, the MNEST database could be loaded from Keras using the load data API. Of the deep learning libraries accept data in the form of tensors. Tensors are special data formats. Think of a simplest form of tensor as an array or a list of numbers or a matrix. There could be higher dimensional matrix as well. So tensors can have any number of dimensions and could be a vector or a matrix. Based on the type of the architecture that we use for the neural network, we need to shape the input data. As a general BKM, a best node method is to actually normalize the data. Also, the labels has to be one-hot encoded.
One of the most important steps as an architect of a deep learning solution is to develop and design the network. A network simply represents the data. The set of input data is transformed by a neural net into another representation. A representation simply represents the data and the patterns embedded in it. Example, suppose we have a set of images of faces of various people and pets. We need to develop a representation of the data. A neural net could actually be developed learning about the data and represent it in a form that becomes the network. So this transformation of input data into its representation is one of the core strategies of a deep learning framework. Now, to do this transformation, we need to first develop the model simply with random set of layers, and then develop another model that overfits, and then gradually iterate and adjust the model capacity so that the right set of patterns can be learned. The approach to designing the network is quite an iterative one. First step is to start and develop the first model, then develop another model that usually is of a larger capacity and can overfit the data. Finally, after a couple of iterations, we will be able to define a model that is right sized, the right capacity, just to learn the patterns that represents the data. so that we could generalize the input data into a representation that can be used to predict quite effectively. So usually the first step is to start with a small model that underfits. To develop the network, we need to actually start with a first model. Usually the first model might be an underfitting of the data to be represented because of the smaller capacity, preventing it from representing all the structure in the data. Next step is to develop a model that is slightly of larger capacity, essentially enabling the network to learn the entire data set. Typically, such a network might memorize and overfit. That is perfectly fine. The next step is to actually define a model whose capacity is slightly lower than the overfitted model so that it can represent the input data in the right format. It just needs to learn the general patterns that is representing the data and not really memorize each and every data point. Such a model would actually represent the data in a very meaningful way so that any other input that comes in, the model will be able to predict quite accurately. We are in the lookout for such a model that just represents the input data. Now let's see how to actually use Keras to actually design the network and implement it. Let's take, for example, two random designs, a two-layer network and a three-layer network. And layer one here would want to define, say, for example, 512 nodes, and then a layer 2, which is smaller, dense layer of 128. And finally, in this problem of MNest, to classify digits between 0 to 9, we need a output which can produce a softmax of 10. Keras exposes very friendly APIs to define a network. Simply add a layer and the network gets created. We add set of dense layers giving the inputs such as the number of nodes in each layer, the activation function, and for the first layer also the input shape. Let's use PyCharm, a popular IDE, to begin this project. The first step is to add this requirements file where we define all the requirements. So the packages gets installed and go through the 7 steps in coding. The 7 steps, as we might revisit, is to define the problem, prepare the data, design the network, compile it and train the network with the training data set, and then evaluate and test the model and do also a prediction. So those are the steps that we'll be doing right now. Loading the data set, MNest load data from the Keras dataset, and then we can see the shape of the training and the test data set. We are plotting it here over here so that we are visualizing what's happening. Then we prepare the data in a way that can be fed into the Keras TensorFlow system. So the main focus is to vectorize the data and reshape it in a way that the neural network can take it in, and also normalize it so that the values are very small, between zeros and ones, and then one hot encode the labels. So to one hot encode, we use two categorical function, and then we reshape it, the input vector, as 28 by 28, and then convert into values between zeros and ones with for normalization. First step is to design the network and compile it. So defining the network is very simple. You just say models.sequential and then add the various layers. We are adding three layers, dense layers. Dense layers are the fully connected layers. The number of nodes, 512 nodes, and we also put in the input shape of the data that is coming in and the activation functions. We use ReLU, a popular one, and for the final layer we use softmax because we want a classification of one of the 10 digits, and so the input data of 28 by 28, 764 is the size of the input data, and we passed it through these three layers: ReLU, Softmax, and Softmax would classify the digits between 0 and 9, one of the 10 values. So the number of nodes here is 10, and we gradually shrink the value from 512 to 128 as uh, we go through the various layers. And that's it. We can then compile the network, and there is a standard cheat sheet on which optimizer and which loss function to use for different types of problems. We'll cover that soon. So here RMSProp, one of the popular optimizing functions, and loss is categorical cross entropy, and then we define the metrics that we need to be measuring, and then we get into the training phase uh, where the the model can now be trained. And training is very simple in Keras. You just call a one line dot fit, and that is your training function. We pass in the training uh, data sets here, the labels and the input values, and then run that for 10 iterations. Same data set, we run it for 10 iterations, and by then the network is trained. We can now compile and test it. So one of the key steps is to reduce the data set to a limited size so that we can just check if everything is going to run. So we're just going to run now till the training function. So if you see, the number of training samples we are using is 2000, and the shape of the input data set here is essentially a tensor. The inputs to the TensorFlow are all tensors here, and if you see, this is a tensor of size uh, 2000, 28, 28, a three-dimension one. And if you see, uh, the values are essentially 28 by 28 pixel sized images, and now this training has begun. So if you see, um, the iterations are running, and as it runs, the various values gets printed. Now let's get into the evaluate and the predict phase. So when you say evaluate, the system would actually come out with the accuracy and the loss values. The final step is to predict. Network.predict would actually predict what is the input tensor here. So the ground truth, the input was 2 and the prediction was again 2. So that's fantastic. So the user scribbled on the screen, and the classifier would then predict what was the user doing. So essentially, The output is in the form of one hot encoded vector. Essentially 2 is represented as one of the 10 classes, and if you see, it's actually representing 2. So the second class, the class representing 2, was activated. And if you see the predicted result, everything else is almost close to 0 except this one is close to 1. So that's how easy to actually define your first deep learning project. Thank you. To summarize, we have learned how to define your first deep learning project using these basic 7 steps. Interesting, we were able to define our first model, a set of fully connected layers, and were able to predict after the training process. So interesting, isn't it? Did we get our business idea implemented? A gesture unlock. Simply draw the screen and you are able to now unlock.